So in this video, we'll talk about some of the general properties of the definite integral. Of course, right now we're just thinking of the definite integral as a way to express the area under the function. So the integral from a to b of f of x dx equals the area of the under the function f of x from x equals a to x equals b. Well, first of all, if we switch the limits of integration, so that we're going from the greater one to the smaller one, so that would be like traveling backwards on the x-axis. By convention, we're just going to say that this counts as negative. So this would be the negative value of whatever the regular integral would be. Number two is, suppose we're integrating a constant function. This would be a horizontal line. Well, of course, the integral from a to b would just be a rectangle. And that rectangle would have a height of c, the height above the y-axis, and it would have a width of b minus a. And so that's a particularly easy one to evaluate directly. Number three, if we scale a function up by multiplying by a constant, then this has the net effect of increasing the area underneath it by that same factor, because of course the y increases and the x stay the same. And so this would just equal c times the integral from a to b of f of x dx. Notice that this is a constant multiple rule for integration. It's the analog of the constant multiple rule we have for differentiation. If we're adding or subtracting two functions, it turns out we can just separate an integral by addition and subtraction. So f of x dx plus or minus the integral from a to b of g of x dx. So addition and subtraction, very easy. Can't do the same thing if we have multiplication or division. Those are cases we'll talk about much later. Finally, suppose we have the integral of a function and we have a point c somewhere in between them. Well, then we could split up this integral into two integrals, one going from a to c of f of x dx and another going from c to b of f of x dx. Now, you may wonder what on earth would be the point of doing that. Normally, it would just be easier just to go directly from a to c. But in particular, say you had a piecewise function. That is a function defined by different algebraic expressions for different intervals along the axis. Then you might have to split up your integral like this in order to integrate a piecewise function. So these are an example of some of the general properties of the definite integral.